All right, welcome back. Let's talk about section 10.4. We are almost done with chapter 10. So let's do this. Section 10.4 is all about inverse trigonometric functions, okay? So right here, I've given you some information. Here's what inverse trig functions look like. This -1 power means inverse. And these are the domains, and you've seen these domains before. Back in chapter 9, when we did section, I believe it was 9.6, you did a little bit of inverse functions. And they ask you if you had like 2 or 3 questions where it's like, if I took the inverse of this, is this possible or impossible? And that's where you were looking at these. As long as that number they were giving you was in this domain, it was possible. Now, we're going to take this a step further, and we want to talk about its interval and the quadrants that it exists in. Okay, so we're going to take this further. Okay, so if the interval, or if the inverse is possible, this is where the answers are going to lie. For the inverse of sine, your answers are going to be between -pi/2 and +pi/2. For cosine, your answers will be between 0 and pi. For tangent, you'll be between -pi/2 and pi/2. Cotangent, you'll be between 0 and pi. Secant, you'll be between 0 and pi, but we do not like pi/2. And for cosecant, you'll be between -pi/2 and pi/2, but we do not like it when y is 0. Okay? So, and then over here, we've got these quadrants. This is a very important table for us. All right? So 10.4 is all about inverse trig. Finding angle measures. All right? So let's just talk about inverse functions. Remember, inverse functions, it's how you undo something. It's like going backwards. So like if I walked up 2 flights of stairs to get to my office, then the inverse of that would be walking down those same 2 flights of stairs. It's undoing what I have done. Okay? So remember in algebra, if I had f of x equal to 2x plus 3, the inverse function of that would look like this. Would be inverse function equal to 1/2 x minus 3/2. Okay? Again, some other things that you would need to know is that functions need to be 1 to 1. Okay? Meaning that every x goes to 1y and every y goes to 1x. Okay? That's what 1 to 1 means. Every x goes to 1y, every y goes to 1x. All right? Some other things. This is how we found inverses. So this is how I took this function and turned it into the inverse. Remember in algebra that you would switch the x and y variables, and then you would solve for y again. Okay? So I would take and I would put x here and y there, and then I would get the y by itself by subtracting 3, hence the -3, and then dividing everybody by 2. Okay? And last but not least, remember that if you know the domain and range of the original, for the inverse, the domain becomes the range, and the range becomes the domain. So that's where a lot of this information in the original comes from, because the range the domain for sine is right here. So this is also this interval, this column you can also call the range of inverse. So the original sine function, the domain for it was -pi/2 to pi/2. And the range was -1 to 1. Hey, those are the amplitude values. The top went up to +1, the bottom went down to -1. Okay? The domain for cosine was from 0 to pi. The range was from -1 to +1. Because again, these were the amplitudes. It went up to 1, down to -1. Okay? So that's what you're looking at here. These used to be the domain of the original function, and this was the range of the original function. But now that we're doing inverses, they flip spots. Again, interval, another name is range for this column. All right. So that was a nice review. So let's talk about this information. So they want you to find the exact value. So they want to know, what is the inverse tangent of -3 or negative square root of 3? Basically, what you're looking at here, what they're asking is, what is the angle, this guy that's right here, when tangent equals negative square roots of 3? That's what they're asking. What is this angle right here when tangent equals a negative square root of 3? So we just use our chart. This is where your chart, your Bible is going to come into play a lot. So all we're going to do is we're going to come into this chart, and we're going to look where the tangent column has a negative square root of 3. Oh, look, here's one of our answers, 120 degrees. So we now know that theta is equal to 120 degrees. But you're not done, because there are two places where tangent is equal, where tangent happens, okay? So right here, it's in quadrant 1 and in quadrant 4, okay? Which is weird because that doesn't make sense for this answer. That's not a quadrant 1, nor is that quadrant 4. Tangent negative square root of 3. We know that it is possible because it's in the domain. Okay? That's the first thing we should have checked. I should have said that first. So you should always check domain first. And since the domain of tangent, if you look at this, is all reals, we're good to go. Because negative square root of 3 is in that domain. So let's go back and let's take a look at this. Negative square root of 3. Tangent. Negative square root of 3. Right there. And it's in 120 degrees. And then let's look at another place. Where else do we have negative square root of 3? Oh, there we go. 330. Stop it. Okay, so it's being annoying, but it's right here. So when we look at this, oh, I get it. I get what I'm doing now. I just forgot for a second. Okay. The inverse function says we want to know where this is happening. And when you look at that graph right over here, it says we only work this within quadrant 1 and quadrant 4. Okay, so when you come back to this, if you look at this, this is not in quadrant 1. Okay? Or in quadrant 4. So we only deal with quadrant 1 and quadrant 4. So because this angle is not in one of these two, you have to throw it out. So this is the only angle that's left. Now the other thing you got to look at is look at how they want their answers. Your answers are between negative pi halves and a positive pi halves. Okay? See if I can get rid of this blue. There we go. All right. So our answer has to be between negative pi halves and a positive pi halves. So this angle is in quadrant 4, but it's too big for us. We need this angle in terms of radians, but as a negative number, okay? Because it got to be between 90 degrees and negative 90 degrees. They do not want it as the positive version of the angle. So what we need to do is we need to take and subtract 360 to this. We're going to use coterminal to help us out. So if I take 300 degrees minus 360 degrees, I get negative 30 degrees. Sorry, negative 60 degrees. My mind is just off key today. And what is negative 60 degrees as radians? Because they do want radians. Well, you just take that and multiply it by pi over 180. Gives you negative pi over 3. And that's the answer they're looking for. Okay. So make sure you definitely pay attention to those directions. Looking at this, they love radian measures. They love radian measures. Yeah. So unless it says degrees, you're always going to give us radians. So you got to be careful. So again, running through things. So the first thing you're going to want to do is make sure that whatever number they have is in the domain. Okay? That's what we did right here. We checked it. The domain was all reals, and so this number is definitely in the all reals. Okay? After that, we found the two angles. Okay? Using your chart. That's where we got the 120 degrees and the 300. Then from there, you got to find, or not really find, but pick the angle according to inverse quadrant. So that's where we got rid of the 120 and we picked the 300. And then last but not least, adjust angle according to inverse range. Or in our case, the range is what they call the interval. Okay, that was that interval that's right there. We had to adjust it so that it fit within this interval. All right, so that's it. First, make sure it's possible, because if it's not possible, you don't do any of this. Then you find your two angles. Then you're going to throw one of them out, or maybe you'll keep both of them because both of them are in the inverse range, okay, in the quadrants. And then you adjust. Sometimes you have to adjust, sometimes you don't, okay? Go ahead, try this one on your own. Okay, so the cosine domain is from -1 to 1. So is this number within that interval? Well, just if you don't know if it is, go to your calculator. Alpha y equals negative square root of 2 over 2. Hit enter. And that number is definitely between negative 1 and 1. So we're good to go. We can do the inverse of this. So a couple things to note. So the inverse is going to be between 0 and pi, and the angle is either in quadrant 1 or quadrant 2. All right. So our answer needs to be between 0 and pi, which is quadrants 1 and quadrant 2. All right, so let's go to our chart and let's find where cosine is negative square root of 2 over 2. Because what you're looking at here is you want to find the angle when cosine has an answer of negative square root of 2 over 2. So we go to here, and we're going to look at the cosine column. Here it is. And we need negative square root of 2 over 2. Well, that's positive. That doesn't work. Oh, here's a negative 1. So 135 degrees. So theta could be 135 degrees. And if we scroll on down, there's another one, 225. So looking at this, the angle that we have to throw out is going to be the 225 because that's in quadrant 3. So this is our quadrant 2 angle, which in radians is 3 pi over 4. And the cool part is you stop right there. That is the answer. You don't have to adjust it because you just got to be between 0 and pi. And 3 pi over 4 is between 0 and pi. So that is the answer they're actually looking for. No adjustment needed. So like I said, sometimes you have to adjust because you might have negative radians that they want you to be in. Sometimes you don't because this is actually within that interval. And there you go. That's all 10.4 is about. Try it again. Okay. So the domain of sine inverse is negative 1 to 1. And we like the negative 1 to 1 because of the brackets. So can I get away with doing the inverse of this? Absolutely. It is in the domain. 1 is in this domain because we have a bracket. Okay. So some things to consider again. With sine, our interval is from negative pi over 2 to pi over 2. And it's either in quadrant 1 or quadrant 4. Okay. Oh, there we go again. There we are. So our answer is going to come from negative pi over 2 to pi over 2. And that's either in quadrant 1 and quadrant 4. Okay. So again, what we want to know is when is sine theta equal to 1? So that means our theta can be, so we go to our sine column. Hey, there's a 1. So that's at 90 degrees. And is there anybody else? Nope. That's it. So 90 degrees, which in radians is pi over 2. And there's nothing else to do because that does actually fall within our range. Okay, it's a quadrantal angle, so technically it's not in any one of these quadrants, but it's good because it is a part of our range right there. And there you go. That's it. Dunsies. Moving on. Try it again. So I misspelled this. This should actually say arc sine. So arc just means that it's the same thing as if I just had sine negative 1. So sometimes they do sine negative 1. Sometimes it'll say arc. Okay? There we go. Forgive me for the misspelling. So, pause the video and go. Okay. So again, we're dealing with sine. And the domain of sine is from -1 to 1. So yes, -1/2 is in there. Remember that our answers fall from -π/2 to π/2. Okay? Which is quadrant 1 and quadrant 4. Okay? So again, what you're looking for is what is angle theta when sine equals -1/2. So we go to our list. And when is sine a -1/2? So not there. So we keep scrolling down. Here's a sine at a -1/2. So that's 210 degrees. Here's another sine at 330 degrees. Okay. So 210 degrees and 330 degrees. So that means since we got to be in quadrant 1, quadrant 4, we're going to throw 210 out. That's quadrant 3. So here's our angle. Okay? But again, we need to be between -π/2 and a positive π/2. So in other words, that's between -90 degrees and a positive 90 degrees. So we actually do have to adjust this angle. Take 330 minus 360. That gives us -30, and convert that into radians, which will be -π/6. And that's what they want. If they wanted the degrees, you'd say -30. Okay? Any questions so far? Well, I mean, actually, not that you could actually answer me. So, but hopefully you don't have any questions. I mean, it really is this simple. I mean, this is what you're supposed to be doing. Okay? Every time. All right. Another one. Go ahead, pause the video, give this one a shot. Okay. So, the domain of secant is from -∞ to -1, and then jump over to 1 to infinity. So from -∞ to -1, jump over to, that's a horrible union, 1 to infinity. Okay, so is -2 within these intervals? Absolutely, it's in this guy. So we can continue on. So the answer to secant must be between 0 and pi, but we do not like π/2. Okay? So between 0 and pi, but y cannot equal, double check that, π/2. And I need a bracket around the 0. No π/2. Okay. And that means this happens in quadrant 1 and in quadrant 2. So again, you're looking for what is secant theta when the answer is -2. So theta equals, go to our chart. We need secant, so it's right here. When are we -2? There's one, 120 degrees. And the other guy is 240 degrees. 120 degrees and 240 40 degrees. According to the quadrants, 240 is out. And 120 in radians is 120. Scroll back up to the top. 2 pi over 3. And you do not need to adjust that, because that is within the interval. Okay? Easy peasy. Do it again. Okay. So again, in here, arc sine from -1 to 1. There's our interval. There's our quadrants. So the domain is -1 to 1. That's definitely in that domain. So our answers are going to be negative pi halves to pi halves, which is quadrant 1 and quadrant 4. Okay? So when we run this, again, arc sine just means you're looking for sine. Sorry, this should be in red. Trying to keep with my same colors. Sine theta is equal to negative square root of 2 over 2. When does that happen? So theta equals, sine is this first column right here, pretty sure. Yep. We just need to see when is this negative square root of 2 over 2. So here's one, and there's the other. So 225 and 315. 225 degrees and 315 degrees. So again, according to the quadrants, you have to throw 225 out. This angle is too big for this, so we're going to subtract 315 from 360. That will give us negative 45 degrees. And in radians, that is negative pi over 4. Okay? All right. Should be getting near the end. All right. So now we want to use the calculator. All right. So you're going to use the calculator to find the decimal degrees. In this one, usually what they are having you round to, it says 4 decimal places. So round to 4 decimal places. Okay? So when you go to your calculator, this is when we're going to be using the sine -1, cosine -1, tangent -1, because these are inverse functions. And again, you've already used these before. So just go to your calculator and let it do the dirty work for you. If it doesn't work, your calculator will let you know. Okay? Losing my piece. So all I want to do is go to my calculator and plug in cosine inverse 3/5. And we're going to round to 4 decimal places. So second cosine alpha y equals 3 over 5. Close it, enter. And there you go. And we are in degrees because it said it wanted it in degrees. And 4 decimals would be 53.1301. Okay? And that's all you got to put. 53.1031? No, 1301. 1301 degrees. All right. Try that one. All right. So let's talk about this one, because if you go to your calculator and we say, wait a minute, There's no cosecant. How do I do this in the calculator? Because I don't have an inverse cosecant on my calculator. Well, again, think about what this means. Okay? They are asking you, what is theta when cosecant equals 5.01? How else can I make cosecant? Well, remember that it is 1 over sine theta. That equals 5.01. Okay? Now what's cool is we have a property that says, hey, if these two truly are equal, I can take and flip both sides. It's a reciprocal property of proportions. So 1 over sine theta equals 5.01 over 1. Then it is also true that sine theta is equal to 1 over 5.01. And again, that makes sense because these are just reciprocals of each other. So the reciprocal of cosecant is sine. The reciprocal of 5.01 is 1 over 5.01. And now you know exactly, hopefully, what you should be doing. We want to run the inverse sine of 1 over 5.01. Okay? That's what you need to be putting in the calculator. So whenever you're dealing with secant, cosecant, and cotangent, you need to be running the inverse of the reciprocal of the number. Okay? Run the inverse of the reciprocal for the corresponding reciprocal trig function. So we're going to go to our calculator and we're going to run this. So we'll go to our calculator, we'll hit second sine alpha y equals 1 over 5.01. Hit enter, and there it is. So 4 decimals is 11.5136. Okay? 0.5136. So 11, oops, I want this in blue. 11.5136 degrees. It is 5136. Yep. And there you go. So just be careful on the ones when it's secant and cosecant and cotangent, because we don't have an inverse trig function on our calculator. You got to think about it in terms of its reciprocal function. Okay? All right. And then I only got 2 problems left. And basically what I want you to do is I want you to work inside the parentheses first and then work outside. So some of these you're going to be taking an inverse and then dealing with the regular function. And others you're going to be taking the regular function and then deal with an inverse. Like in this guy. Well, actually, sorry, in this one. So I actually got 3 more. Okay. So all of these again, let me make sure of that. Yeah. All these again want the exact value. Okay. So let's talk through this guy real quick. So first, just focus in on the inside. We want to know, when is the angle for cosine 3/5? Okay. All right. Now, when you're dealing with this, because if you go to the if you go to the calculator, it's going to be giving you some weird information here. Okay? Because if you go to our chart, this is not on the chart. All right. So what you need to do again is think about what's going on here. They are asking you, what is cosine theta of 3/5? Oh, wait a minute. I've seen this kind of information before. Remember, this is like x and r. If you found the y value, you know exactly what you're dealing with. Okay? So this is taking us back to what we did in 9.5. We know that this is x over r. Okay? Well, if that's x, we want to figure out the y value. And your r is 5. Okay? Remember that we are dealing with x squared plus y squared equal to r squared, or again, it's the square root of this guy. Okay? So either one, x squared plus y squared equals r squared, or square root of x squared plus y squared equals r. I myself, I'm going to deal with it as the x squared plus y squared equals r squared. Okay? So let's just plug in and let's do some quick math. So the x is 3 squared plus y squared equals 5 squared. Okay? So from here, that's going to be 9 plus y squared equal to 25. Subtract 9 to both sides, you get y squared equals 16. And then now you're going to take your square root. Okay? So y equals plus or minus 4. Now we got to figure out, is this going to be a positive 4 or a negative 4? Well, let's think about this. This is where knowing about the interval for cosine, where you're going to get your information. Right over here, it says the interval for cosine is in quadrants 1 and quadrants 2. Okay? This guy is in quadrant 1 and quadrant 2. What do you know about points in quadrant 1? Both the x and the y are positive. What do we know about points in quadrant 2? The x is negative and the y is positive. So we know that this guy is actually coming from quadrant 1 because my x is positive. So that means the y has to be positive. So now you know that this is no longer a negative number. It has to be the positive 4. Also, if you look up here, no matter which quadrant we picked, the y was going to be positive no matter what. Okay? So now that we know what y is, we can figure out tangent. Okay? So this piece was to give us information to help us solve for y. Now that we know what y is, we can figure all this information out because we know that tangent is equal to y over x. Okay? So tangent theta is equal to y over x. So tangent theta is going to be 4 over 3. And there you go. That's the answer. You could also go to your calculator, check some of this stuff out. So if you take inverse cosine alpha y equals, it doesn't always work, just so you know, 3 over 5. Close it. There's your answer. And then we want to take the tangent of that angle. So hit tangent, go right back up, grab that guy, close it. 1.3 repeating, if you turn that into the fraction. Okay. Should work now. Okay. I don't know why that's not turning into the fraction. So let's hit alpha y equals. Let's go down to number 4. Huh, weird. Well, anyway, 1.3 repeating, if we just kind of take and write out a bunch of 3's and then hit math, enter, there it is, 4/3. Okay, so sometimes you can use your calculator to help you out a little bit. But, I mean, that's really the math that was going on behind it. They were giving you how to find x and r here. And then once you knew what y was, based off of the arc cosine, you can find tangent. Okay? All right, now this one's a little bit easier. So we want to know, what is the following answer? Give it a shot. Go. Okay, so again, let's start in here and think about what's going on. This is a lot like the last guy. So the range of tangent is negative infinity to positive infinity. That's good. So we're in the range. Also remember that in this, we know that tangent, meant to grab the red, that this is saying tangent theta is equal to -6. Okay? Well, remember that this guy is over 1. Remember how tangent is made, that this is the y, this is the x. So you know your point. Okay? Our point is 1, -6. In order to find cosine, we need to find the r value. So you've got a formula, 1 squared plus -6 squared, and we're going to take the square root. Okay? So 1 squared is 1, plus -6 squared is 36. That's equal to r. So your r value is the square root of 37. Now that you know what r is, we can figure out cosine. Okay? So cosine theta is going to be x over r. Okay? Oh, and we don't know if this is plus or minus. Almost forgot about that. So let's go back and double check this thing. So, oops. We know that this is either plus or minus the square root of 37. Actually, wait a minute. We do know what it is. Because it's radius. Never mind. Radius is always positive. Mr. Armstrong's always thinking too much sometimes. Radius is always positive. Okay? So that's good. So we actually do have all the information we need. So the x value is 1. The r value is the square root of 37. So you just rationalize. Times by the square root of 37. So cosine theta is equal to the square root of 37 over 37. Just like last time. Just use that trig that you know back from 9.5 to help you out. Last problem. Try this one. You actually don't need to use any of that other information because we actually know what is pi over 4, or 4 pi over 3. And go. Okay. So, cosine 4 pi over 3. We just go to our chart. We can figure that out. So here's 4 pi over 3. Cosine is right here, so it's a negative 1/2. Okay? So we now know that we want to take the inverse cosine of negative 1/2. Okay? So again, we're going to go in. We know that this is in the domain because the domain is from -1 to 1. It's in the domain. And we know that cosine, its interval, is from 0 to pi, which is in quadrant 1 and quadrant 2. Just to double check, make sure. Yeah, 0 to pi, quadrant 1, quadrant 2. Cool. So if you run this, we go look at our chart. Cosine, we're looking for negative 1/2. There's 210. And another negative 1/2. Oh, sorry, wrong column. That was sine. So negative 1/2, 240. And another negative 1/2 is 120. So we now know that theta is equal to 120 degrees and 240 degrees. According to this, throw out the 240. We're going to keep the 120, but it needs to be in radians. So 120 in radians. You can go back to your picture here. 120 is 2 pi over 3. And there you go. That's what they're looking for. And that is section 10.4. All about inverses. Make sure you pay attention to the domain and pay attention to those quadrants. It's super important. Okay? See you next time.